right, welcome back. All right, now, so we know what we know, okay? Now, let's solve this problem in a couple of different ways, okay? First thing I want to do is I want to do it the old-fashioned way, right? Is that okay? Where I'm going to use this area as a workspace. I know that F net equals FA plus FP plus FF, right?
Yes.
So that's going to be 200. That's plus. I'll leave off the unit labels. Is that all right?
Yes.
Plus negative 125 plus negative 70. So F net equals what? 5, right? Plus 5 newtons, right? Meaning it's going in the positive direction. Remember, that's the motion, right? So if it's plus, it means it's going up.
Yes.
But first, an announcement.
Can I please have a custodian come up to the main office? Can I please have a custodian come right outside the main office? Thank you.
You're welcome. You've heard of Rocky the Flying Squirrel?
No.
That was just Rocky the Flying Squirrel. Our principal sounds like Rocky the Flying Squirrel. She does. Wonderful person. Just sounds like Rocky the Flying Squirrel. Okay. Now, so that's that, right? Plus 5,
Yes.
right? And how do you know it's plus 5 in that direction? Because it's positive, right?
Yes.
That's the direction of the motion is up. So if it's positive, it means it's going up. Correct?
Yes.
If it were negative, it would be sliding back down, right? All right, so far so good? All right. All right, so I can erase that then, right? Is that correct?
Yes.
I can erase that? Okay, so the F net, so we'll put right here. We'll put right here. Can you see right here? Can you see this?
Yes. Let me double check.
Is going to be plus 5 newtons. You're not going to be able to see necessarily all the way over,
Yeah,
but
it's
it has
fine.
some buffer.
Yeah, it's there.
Okay, so plus 5 newtons. You see that? That's F net. Now what's A going to be? A equals right here, right?
F net over.
F net divided by M, which is going to be 5 over 60, which A is going to be what?
0.083.
0.083. Do you get that? Did you get that at home? 0.83, right? And what are the unit labels for that?
Meters per second squared.
Excellent! Okay? We're on the limits of our... Let me just make sure. I'm going to make sure. All right? Now, so far so good? Yes? I'm going to erase, this is our little workspace here, is that okay? I can erase that?
Yes.
Okay, now, I know that this equation is real, correct? In other words, that's up there, right?
Yes.
That's 0 because you're starting from rest, right? Correct? Therefore, true? True?
Yes.
Yes? And then, I'm going to erase this now. Can I erase this just for a second? You see that?
Yes.
Yeah? So, VF equals square root of 2AD. Is that all right? Right? So 2 times 0.083 times 100. Right? You know what, let me write that out a little bit better than that. Is that okay?
Yes.
Is that all right? I'm gonna put in the unit labels. Is that okay? So it's gonna be 2 times 0.083 meters per second squared times 100 meters. Correct?
Yeah.
And what does that equal? You have that?
4.1 meters per second.
4.1 meters per second,
Square.
meters per second,
Meters.
right? Because it's just velocity, right?
Yeah.
Right? Yes? Okay. So, see how that's meters? Meters times meters is meters squared. So that's meters squared over second squared, right? So meters squared over, what's the square root of meters squared over second squared? Meters over seconds, right? Right? Okay. So this, I'm running out of room here. Do you see that this equals, right? You with me?
Yep.
Well done. Yes? That's the answer. Now let's do it another way. Let's do it another way. Okay? All right? Okay, now, let's interpret this in terms of energy. Okay? I started out with a lot of kinetic energy, didn't I? A lot of it. This is what you want to ask yourself. How much kinetic energy did I use to get the skier to the top of the hill? Now let's look at a pizza pie, okay? Right? Let's look at a pizza pie, okay? You ready? A lot of the energy was because of what?
Friction.
FP, right? Right? Which is the same thing as what?
Applied force.
No. W. What's FP? FP times 100 is what up here?
W down.
Yeah, W down, right? Right? So W down. Right? Yes? And then a lot of it was due to friction, right? So what was the only usable stuff? What was the only usable kinetic energy that actually went into mechanical work?
The net hours,
Yeah,
the 5 newtons.
the net force times the 100, right? You see that? So that's it. So everything else went. So this is going to be kinetic energy net, if you will, right? So what's the net kinetic energy?
5 newtons.
What is it?
5 newtons.
No, I asked her what the net kinetic energy is, and she told me a force. So if I say to you at home, what's your weight, and you told me
I did it again.
55 miles an hour, would that make any sense to you?
No.
Okay.
5
What is the net kinetic energy?
joules. 5 joules.
No.
No.
What's work? Let's do it this way. What's the work? What's the work, the mechanical work that I used to get from the bottom to the top? How many? Isn't work force times distance?
Yes.
You sure? You sure? What's the distance? 100 meters, right?
Yeah.
And what's the force?
200.
No. That little sliver, this sliver.
The 5 newtons.
5 newtons. You see that?
Okay.
So,
So 500.
what is it?
500.
500. Bah. Right? Isn't it 500? Isn't it?
Yes.
So, the kinetic energy, we'll call it net, equals 500 joules, right? Correct? Now, how do you get the velocity from the net kinetic energy? Or let's put it this way. Let's reword this. In other words, In other words, we're going to call this the original, all right, what, let's say this, okay? What, all right, I can do this. Okay, what part of the original kinetic energy was converted to work or mechanical work, right? Isn't it going to be Isn't it going to be 500 joules, right? So the kinetic energy net equals 500 joules. So it was all the total kinetic energy I started with, I have to subtract off the down work, FP work, right? I have to subtract off the friction, right? Right, and now I'm left with what? I'm left with
5 newtons.
the 500 joules, right? Okay. Is there a connection between velocity and kinetic energy? What's the connection? Okay, this is
Kinetic energy is the energy it's taking while in motion. So whatever the velocity is, it correlates to the energy that it's taking up.
KE equals positive, KE equals 1/2 mv squared, right? So this is 500, so V equals KE times 2 divided by m square root. Is that right? You get that? You get that? Can I erase that? So V equals 2KE divided by m. Is that right?
Yes.
Yes? Yes or no?
Yes.
You with me? Okay. So therefore, let's plug in. Okay? Let's plug in. Velocity equals 2 times 500 divided by what? 60. Do that out. What do you get?
That's 4.
4. We did a lot of, to get that 5, didn't we do a lot of rounding? Yeah. Same thing, 4 meters per second. You get it? You get it or not?
Yep.
Okay, now, this is the last question and then we're done. You know what? I'm going to turn it off. What part is this?
Part 3.
Part 3? Okay. I'm going to come back and do part 4. But I'm going to erase everything but anything to do with work. Okay? I want to know work, ideal, okay? Anything that has nothing to do with anything but work, I'm going to erase, okay? I'm going to redo it, and we'll come back and we'll finish part 4. Clear? See you later.